Hey guys, so I have a question for you. Imagine a galaxy whose light took 25,000 years to get to the Earth. How far away is that galaxy? Well, you might say 25,000 light years away, right? And that is correct. But now imagine a galaxy whose light took 13.4 billion years to get to us. How far do you think that galaxy is? You might be tempted to say that it is 13.4 billion light years away, but in fact that galaxy is actually 32 billion light years away. So how is all this possible? Is light traveling faster than it should? To answer that, let's travel to a galaxy named GNZ11, which was discovered in 2016. It took about 13.4 billion years for that light to get to us, but the galaxy right now is 32 billion light years away from us. How is this possible? If the universe was just like this stagnant thing, let's say these two objects are where they are, and light is emitted from this object all the way to this object. If nothing moved and it took 13.4 billion light years to get across from one to the other, then they would be 13.4 billion light years apart. But imagine the space between all the objects are expanding with everything. So as light is traveling across, the distance between these objects is getting larger and larger. So even though it took light 13.4 billion years for GNZ11 to get to us, we are now 32 billion light years away from that galaxy. The universe expanded in that time. I think this is the most unintuitive things about the universe. Space itself can expand. When I first realized that the observable universe is 13.8 billion years old, the edge of it should be 13.8 billion light years away. People don't always talk about distance when they talk about light years, but it's not. It's actually 46.5 billion light years away. I was so confused. How is the universe so much bigger than light has had time to get to us? But it makes sense because all of that space is expanding and stretching in the entire universe. Space is not this stagnant thing. It's not like those objects. All of this space-time is spreading apart, and there's more and more space being created, and the effect of that is that space is expanding with the galaxies and carrying them apart from each other. You start to notice that galaxies are actually receding away from us. So the further away they are, the faster away they're moving from us. Something that's a megaparsec away from us is moving at 70 kilometers per second away. Something that's twice that, or 2 megaparsecs, is moving at 140 kilometers per second. You can keep going until you get to 299,792 kilometers per second, or the speed of light in a vacuum. So eventually, until you get to that speed, you plug it into your equation and you get that the distance away from us to a galaxy that is moving away from us at the speed of light is about 14 billion light years away. And that is far within the boundaries of the edge of our observable universe. So here's us. We're, where we are in the center of our observable universe. And if you go in all directions out 14 billion light years, you get a sphere. That sphere is called the Hubble Sphere, beyond which everything is moving away from us faster than the speed of light. And it's not just a little bit of stuff. It is 97% of all galaxies in the universe are moving away from us faster than the speed of light. Here's another question. Do you think we can see matter that is moving away from us faster than the speed of light? But first, how can matter move faster than the speed of light if the speed of light is the fastest thing in the entire universe? According to Einstein's special theory of relativity, which says that nothing can move through the universe, through space, faster than the speed of light. And while that is true, space itself can expand, and the space between two objects can expand such that it moves those two objects apart faster than the speed of light. So nothing is actually violating the special theory of relativity. Nothing is actually moving through space faster than the speed of light. Back to the original question. Can we see things that are moving away from us faster than the speed of light? So that galaxy that we talked about in the beginning, GNZ11, that galaxy is about 31.96 billion light years away from us. So that galaxy is moving away from us like 3 times faster than the speed of light. We're seeing it as it was 13.4 billion years ago. Now it might not even be there anymore. All the stars could have burnt out, or they could have been swallowed by another galaxy. It's pretty crazy to think that we're seeing stuff that might not even be in existence anymore. So there are some galaxies that are moved away from each other by space fast enough that we will never see them again as they are now. But there are some galaxies that are outside of our Hubble sphere, assuming that they're moving away from us faster than the speed of light, but we will be able to see them as they are now. So they're emitting light now, and it will get to us. Okay, so the galaxy is moving away from us faster than the speed of light, and it emits light at us, and that initially that light is moving away from us, but it's traveling through space until it gets inside of our Hubble sphere, and it's no longer moving away from us. So let me draw this out. Here's us, and then here's like shells of distance away from us. So imagine like this is the Hubble sphere. So this galaxy is moving away from us faster than the speed of light because of the expansion of the universe. It emits light towards us, which initially is moving away from us, because this light was emitted from this object going faster. So it's going to be moving away from us, but it's making its way slowly this way, even though space is expanding. It's making its way slowly, and then eventually it's going to get to distances that are closer to us. So think about it like this. Remember how I talked about consecutive distances, or distances that are further and further away from us and are moving faster and faster. Let's say this is moving at a speed of 10, this one's moving 20. So as light goes this way, now it's going into space that's moving less and less fast away from us, because of the expansion rate of the universe, or the Hubble parameter, is slowing down, which means that stuff that's now at the first circle is not moving away from us as fast as stuff that was here. The light does this crazy path, sort of like a boomerang, where light emitted here goes forward away from us and then comes back towards us, eventually gets to us. So as light gets closer and closer to us, it starts moving faster relative to us. There are galaxies outside of what we call the event horizon, or the cosmic event horizon. And outside of that, all the galaxies and matter out there will never be able to see or contact them, and they'll never be able to send light back to us. What you might be thinking, is the Hubble sphere the same thing as the cosmic event horizon? Actually, no. Those are two different things. Inside the Hubble sphere, everything is moving slower than the speed of light. The event horizon is everything that we can see. There's actually a boundary between those two. It's like a shell between those stuff that's moving away from us faster than the speed of light now, but the light being emitted from those things now will eventually get to us, and that's what's inside that shell. Also, our Hubble sphere is also expanding. More light is coming inside of our sphere of things that are moving away from us faster than the speed of light, because the universe is expanding. But since the universe is expanding, the light can be emitted from a galaxy initially will be moving away from us to start, and then eventually stop and start coming towards us relative to our perspective, which seems like that's violating special relativity, but it's not, because it's still moving through space at the speed of light. I hope you enjoyed this video. If you did, don't forget to subscribe, and if you haven't yet, hit the bell to be notified when I release my latest video, and thanks for watching.